My name is Martin Kühne. I'm the tunneling project manager for the 380 kilovolt Berlin diagonal power link. The power link is Berlin's extra high voltage grid, carrying 380,000 volts of electricity into the city. The new cable being laid here in the tunnel has a higher transmission capacity than the existing buried cable, 2,500 amps, compared with 1,600 amps. We're now at the start shaft for the power link below Rudolf-Wissel Bridge. This section passes through Charlottenburg, then crosses Straße des 17. Juni to the Mitte substation in Bissingzeile. This start shaft consists of 3 individual shafts. This is because the tunnel boring machine, or short TBM, needs at least 40 meters in order to be correctly installed, so that it can start tunneling the first few meters. The TBM has an excavation diameter of 3.88 meters, and the ring being installed at the rear has an internal diameter of 3 meters. Each ring we're installing weighs almost 10 tons. For comparison, the cutting wheel weighs 20 tons. This massive steel structure is specially adapted to the Berlin soil, so that it can excavate the sand efficiently and advance in a controlled way. The TBM has a total length of 155 meters. It weighs just under 408 tons and has a forward propulsion force of almost 1,700 tons. The machine has to be continually supplied with segments as it advances. At the same time, pipes and tracks also have to be brought in. All this is done using the tunnel locomotive and its wagons. This also has a passenger carriage to get workers to the TBM for the day and night shifts. The machine we're using here is called a mix shield. It is specially adapted to the Berlin subsoil. Where we're tunneling, there's a lot of water as well as soil. To excavate the soil in a controlled way, we use a liquid known as slurry. This ensures that we only excavate the exact soil that we tunnel through with the machine. Once we've advanced 1.2 meters, these precast concrete elements are installed at the rear of the TBM, about 12 meters behind the cutting wheel, under the protection of the shield. Once they are installed, we can advance another 1.2 meters. One of the major challenges with this kind of tunneling is the small diameter. The 3-meter diameter is taken up by the TBM, so the workers have to move around on the machine. That's very physically demanding because they don't have room to stretch properly. It's also extremely hot down there. The TBM is operating 24/7. The teams work 12 hours on, 12 hours off, alternating between day and night shifts. The Berlin diagonal power link is important for the energy transition because the increased transmission capacity will also allow us to transmit renewable energy. At the same time, it's obviously vital for the capital's electricity supply.